So this is we'll do a simple linear regression analysis on the two variables. So we have here books. Books in here is specified as the number of books that the individual has read for 1 year, and the other variable is TV viewing, which is conceptualized as the number of hours, or operationalized as the number of hours that the individual watches television in a day. So we are conceptualizing that the amount of TV viewing may be predicted by the number of books the individual reads in a year. So more or less, probably it would be intuitive to conceptualize that the more books you read, the lesser you view television. So to do that, so we'd like to know whether TV viewing can be predicted by the number of books read in a year. So to do that, we will do a simple linear regression. So we click on Statistics, Multiple Regression. Then we identify our variables. So our dependent variable, or the one which we are predicting, is TV viewing, and our independent variable, or our predictor, is the number of books read in a year. Let's click OK. Click OK again, and then click on Summary Regression Results. Okay, so in here there are a couple of things that you would like to look into above. So you have here R, which is basically the correlation between the number of books read and TV viewing, which is relatively high. And then this is the variance explained. So this suggests that so this is 0.52. So if you convert that into percentage, it's suggesting that 52% or 52.5% of the variance in TV viewing may be explained by the number of books read. And in here we have the adjusted R, so which may be used alternative to the R, but probably this would be a more accurate value, since this is the adjusted R. So perhaps we can say that instead of 52.5%, 46.6% of the variance in TV viewing can be predicted by the number of books read. Okay. But I think this kind of information becomes even more important when we go to multiple regression. So for the meantime, so just so you know, so those are what those values mean, and this F test actually determines whether our predictor significantly predicts our outcome variable, whether the number of books read significantly predicts the amount of TV watching by the individual. And we can see here that it does significantly predict it at a p-value of 0.01772, which is much less than 0.05. Okay, so now let's go here in this particular table. So we have here the intercept. So the intercept basically, particularly the regression coefficient of the intercept, basically tells us the value of TV viewing if our predictor is 0. Okay, so it's suggesting that if you do not if you do not read any book in a given year, then this would be the value of or this would be the average, or the estimate number of hours of TV viewing in a day. Okay. All right. So again, this is what you call as the unstandardized regression coefficient, which is the units of these values are the original units, which in this case we are predicting number of hours of TV viewing. Okay, all right. So in here would be our predictor, so the number of books, and its regression coefficient with TV viewing is negative 0.62500. All right. So this means that so since it is highlighted, so the probability values is suggesting that the number of books read in a year does significantly predict the hours of TV viewing. And if you notice, since we only have one predictor, the p-value here is pretty much the same as the p-value we have here on top. Okay. All right. So what does negative 0.625 mean? So since we are regressing TV viewing on the number of books read in a year, so this can be interpreted as, and remember this is a negative coefficient, so this suggests that there is a negative relationship, or there would be a negative prediction between books and TV viewing. So we can interpret this as, so listen carefully, for every one book read in a year, TV viewing will decrease because of the negative sign by 0.625 hours. Again, so for every one book read, TV viewing will decrease by 0.625 hours. Okay. Now, to know whether this is significant, it has been converted into a standardized value, and the standardized value of this coefficient is this one, which we also call as the beta. So this is again the standardized regression coefficient. So this is no longer in the original units of the raw scores, but this is in the original unit. Okay, so to determine whether this is significantly different from 0, we have performed a t-test, and this particular t-test, it is suggested by the software, by the analysis, that this is significantly different from 0, as evidenced by our probability value, which is less than 0.05. So more on regression analysis when we do multiple regression. So for the meantime, so this is simple linear regression using Stitistica.